All right, so welcome back to everyone. A very warm welcome to all of you, my dear students. A very warm welcome to all of you. So, guys, in this session, guys, in the last session, we were talking. In the last session, guys, we have been speaking about the vectors in Cartesian. Okay, so in the last session, guys, we have spoken about the vectors in Cartesian. Now, in today's session, guys, what we are going to do? In today's session, we are going to take it further. Okay, we are going to take this further. So, before that, let me introduce myself. My name is Dr. Umashankar, and I am your physics educator. I have done PhD and MTech from Indian Institute of Technology, Roorkee, and these are some brief credentials of mine. So, I welcome all the live students to the session. Okay, warm welcome to all of you. So, the session started somewhat late today. Okay, so due to some technical issue. Okay, so I hope that sometimes, see, when we are working in the world of technology, sometimes technicality may happen. Okay, so we must not mind it. So the live students, welcome to the session, and those who are watching the recording also, you are also very welcome to this channel. Okay, so guys, in the last session we have dealt with. In the last session, guys, I have introduced you to the world of vectors in Cartesian. Okay, vectors in Cartesian coordinates. Okay, so now in the last session, guys, we have introduced the unit vectors, we have introduced the orthogonal unit vectors. Okay, so what was the conclusion of the last session? So if you haven't watched the last session or the session of the vectors, so like parallelly we are going into this vectors and motion in a straight line together. Okay, so in the motion in the straight line we have done till the graphs and kinematics, and along with that we are doing with the vectors, because vector is a very important topic. It is going to be helpful to you when you will be dealing with this motion in a plane thing, and when we'll be talking in the forces also. So in the last session we come to understand that when we have this three direction, so the unit vector in the direction of x, we call it I cap, this is what we call as the j cap, and this is what we call as the k cap. Okay, and when we have to represent the vector in Cartesian, so ax, okay, I cap, AY J cap, and AZ K cap. AZ K cap. So this is going to be the thing, right? Okay, so when we talk about this vector thing, guys, we are having to represent the vector in the form of, okay, in the form of this thing, okay, in the form of this, right? AXI plus AYJ plus AZK. Okay, so in this case, what is AX, AY, AZ? So these are nothing but the components. These are nothing but the components of this vector in X, Y, and Z direction. I hope you remember that, right? Okay, so we learned to see the angle also, so many things. And if we talk about the magnitude, if we talk about the magnitude of this vector A, it was going to be ax square plus ay square plus a z square plus a z square. I hope it is fine to everyone, right? This much we have done. This much we have done in the last session. Okay, okay. Now let's talk about the addition. So we know the magnitude, we knew from where it came from, what is unit vector, what is the relevance. So unit vector is only having one purpose to go for. That is, it gives the direction of some vector. Okay, it is a representation to the vector into some direction, right? Okay, okay. Now let's move to one important portion of this. So that is what we call as addition. So we did the addition of vectors previously also. Now we are going to see the addition and subtraction, that is similar to what addition means. So addition of vector in Cartesian. Okay, so if we need to add the vector in Cartesian and this is having a high relevance, so we will talk about it. So basically, see what happens. So let us suppose, so the live students, please welcome to the session. Okay, so let A vector, so let's suppose we have two vectors in the Cartesian, AXI. We have two vectors in the Cartesian. One is AXI plus, let's suppose, AYJ. Okay, and we have one more vector, that is the B vector, and this is BXI plus by of j. Okay, now I need to add these two vectors. Okay, so when I'll be adding these two vectors, let's suppose the resultant is r bar. So we know when two vectors are added, this is written like this. An addition of any two vector is again a vector, so r is a vector. Now if you want to represent this r vector, you can represent it like this also. Now in Cartesian, rxi plus ryj, rxi plus ryj. Do you copy this or not? Yes or no? Please answer me. So see, all you have to do, see, simply I'll first give you the what you have to do, then I'll show you how it happens. So let's suppose this is going to be the r vector. So what is this rx? What is this rx? So simply you have to add ax plus bx. So see, it is so very simple. See, no use of brain. Very, very simple thing. So how it is so simple? See, very simple it is. Very simple it is. The only thing you have to do, you have to add the multiplier of the unit vector in each of the directions. So if I vector, so A is having ax, that is the component of A vector in x direction. Okay, component of bx is what? It is ultimately the component of b vector in x direction. So you have to add ax bx and ay by. So you can write it like this. So what is the r vector? So just you have added the components of both the vectors in x direction and components of both the vectors in y direction. Okay, can anything be more simpler to this? Right? No, sir, this is extremely simple. This is extremely simple. So how it happens, how we can do it? See, that is why in the last session I've given you the feel of this Cartesian thing. So let's suppose we are having two vectors. Let's suppose one vector is A and another vector, let's suppose, is B. Another vector, let's suppose, is B. Okay, like this. Okay. Now we understand that the addition to this vector, if we are going to add these vectors, so this is going to be the resultant to it. Na? That is going to be the r vector. That is going to be the r vector. So see, what is this A, guys? What is this A? So this A is going to be the, so if I write this r, if I write this r, so can you believe that, so this is this length, this is, so what is this? This is rx only, na? This is the component of r in x direction. Do you copy it? Yes or no? Is it fine? Yes, sir, absolutely, sir. This is the component of r in x direction ultimately, and from which this, so if I say, if I break it down, so it is going to be ax, which is the component of vector a in x direction, and bx. So ultimately guys, what happens, this rx is equal to ax plus bx, right? Rx is equal to ax plus bx. This is what we have seen. As simple as that. See, the components, the multiplier to this I vector, j vector are nothing but the components only, we know it. Now similarly, if we see in this y direction, okay, so if I take the component of this r in y direction, this is going to be ry, this is going to be ry, right? And this ry, from where this ry comes from? So, sir, it comes from the component of vector A in y direction and the component of vector B in y direction. Okay, so ry is what? Sir, it is ay plus by. Okay, ay plus by. So simply, sir, simply see, in questions we don't have to do this way. We don't have to think this much. Because in questions when you are doing so, we have one more thing to do. We have one more thing to do, that we must also do it in less time. Okay, we have to save some time also, right? So when we want to save some time, so right away what we can do, sir, right away what we can do, so we can do this thing that we sum up the I1 and we sum up the what, wow, j constants, okay, the factor which is multiplied with I in both of it and the factor which is multiplied with j in both of it, you can simply have them added. You can simply have them added. I hope it is fine to everyone. Yeah, please answer me. Right. The live students can respond to me. Now, in the same way, see, in the same way, it is very, very simple. If we want to add two vectors in three dimensions, let's suppose a vector is ax of I cap, ay of j cap, az of k cap, okay, and b vector is bx of I cap, by of j cap, and bz of k cap. So what is going to be the vector a and b? What is going to be the vector a plus b? So see, it's as simple. See, nothing can be more simple to this. So you have to add the x components, the y components. You have to add the x components, the y components, and the z components. So it is going to be ax plus bx I, okay, ax plus bx I plus ay plus by j, okay, j cap, then az plus bj k cap, az plus bj k cap. So this is how simply you can do the addition of two vectors when they are available in Cartesian, or when you can think of them as Cartesian. Okay, when you can think of them as Cartesian. Okay, I hope it is fine to you. Right. Now, let's do something. So, just for the sake of, this settles down in your mind, let's suppose we have a vector, okay, which is 8i plus 6j plus 4k, okay, and b vector, which is 4i plus 3j plus 3j, okay, plus 2k, okay, cap. Right? So I cap, j cap, k cap, we very well know these are the orthogonal vectors in x, y, and z direction. Okay, now if I ask you, sir, give me vector A plus vector B, okay, and give me vector A minus vector C. Now, what is going to be your answer? Can you please tell me? Can you please tell me what is going to be your answer? Please solve it. I'm very sure we can do. Very, very simple. Vector A plus vector B and vector A minus vector B. Okay, very, very simple, extremely simple. Please go for it. Please go for it, beta. Please go for it. So how can we be doing it? So see, vector A plus vector B, this is going to be 8 plus 4. That is, so see what you have to do. You have to add the x components, you have to add the y components, you have to add the z components. So it is going to be 12y, it is going to be 9j, and this is going to be 6k. Now what is going to be a minus c, sir? So you have to subtract the x, y, and z components individually. So 8 minus 4, it is going to be 4i. 6 minus 3, it is going to be 3j, and 4 minus 2, it is going to be equal to 2k, right? Okay, so we have a minus b and we have a plus b. Very, very simple, right? Very, very simple. Okay, okay, very, very simple, isn't it? Isn't it? Yes, sir, absolutely. Now, if I say, let's make one more question. Okay. So if we say that a vector is equal to 2 I cap plus j cap, okay, b vector is equal to 3 j cap minus k cap, okay, and c is equal to 6 of I cap minus 2 of k cap, okay, then the value of a vector minus 2 b vector plus 3 c vector plus 3 c vector would be, okay, would be, so it is going to be 20i plus 5 of j plus 4 of k, okay. Option B is going to be 20 of I minus 5 of j minus 4 of k, and C option is equal to 4 of I plus 5 of j plus 20 of k, and D option is going to be 5i plus 4j plus 10k. Okay, now can we try this one? Let's try this one. I'm very sure we can do it. Please go for it. Please go for it, my dear students. Please go for it. I'm very sure we'll be able to do it if we try to. Please go for it, guys. Please go for it. So see, it's a very, very simple. So very, very simple. So A vector, B vector, C vector is given. Now you have to do A minus 2B plus 3C. So let's write them. Let's write them. So we have A. A is the 2I plus J. This is 2I plus J actually. So it is 2I plus J. Okay. Then we have minus 2 of B. So 2 multiplied to B. So it will become 236 of J minus 2 of K. 6 of J minus 2 of K. And this is the, okay. And we have plus 3 of C vector. So it will become 3 into 6, that is 18 of I. And 3 into 2, that is 6 of K. 6 of K. So this way it is going to become C. See, you have to add the items with items. See, as simple as that. You can memorize this way also. All the items are to be added. All the terms with J are to be added. All the terms with K are to be added. So if you add the terms with I, it is going to be 18 plus 2, that is 20. It is going to be 18 plus 2, that is 20. Then we are going to have, see, the terms of j, so it will become minus 5j. So see, 2i plus 18i is equal to 20i, j minus 6j, that is minus of 5j. Then we have plus 2k minus 6k, so that is minus of 4k. So what is going to be the answer? The answer is going to be the B option. I hope it is clear to everyone, right? Okay. Okay, wonderful. Now let's move ahead. Let's move ahead. So now let's write one more question. So determine, let's do this. So determine that vector which when added, determine that vector which when added okay, which when added to the resultant, which when added to the resultant of a vector, that is 3 of I minus 5 of j plus 7 of k, and b vector is equal to 2 of I plus 4 of j minus 3 of k gives unit vector. Please think before you answer. Gives unit vector along y direction. Gives unit vector along y direction. Now can we please try it? Please go for it. I'm very sure we can do. Can we try this one? Determine that vector which when added to the resultant of vector A and B gives unit vector along y direction. Please go for it. Let's try it. Let's try it. Let's go for it. Let's go for it. I'm very sure we can do. Please try it. Please try it. So how could we do it? So if they determine that vector which when added, determine that vector which when added to the resultant of A vector and B vector gives unit vector along y direction. Okay, along y direction. So guys, what is going to be the resultant of A and B? So sir, we can write the resultant of A and B. So how we can write it? So we have to, my dear, directly add the I components, the j components and k components. So how we can write it? So 2i, so this is I actually. Okay, obviously this is I. So 2 plus 3i, that becomes 5i. Okay, very simple. Right? It is more simpler than what we have learned. So 5 minus 5 plus 4, so this will become minus j, and 7k minus 3k, so it will become plus 4 of k. So this is going to be the resultant. Okay. Now it says determine that vector which when added to the resultant of this. So we have the resultant now gives unit vector along the y direction. Now what does this say? So if there is a vector, let's suppose there is a vector x bar, when you are adding this x bar to this x r bar, we are getting the unit vector along y direction. So what is the unit vector along y direction? Unit vector along y direction is j. Okay. So what is going to be the x bar? X bar is going to be j bar minus r. So what is r? This is j cap minus 5 of I cap minus j cap plus 4k cap. So see, I, j, k and cap are the same thing. Okay. I sometimes miss writing the cap. I told you previously also, because ultimately sir, we need to get to the right option, right answer, and in minimum time. Okay. So that is why I am always in a hurry in physics, right? So I sometimes forget to write this gap thing, so don't mind it. Now, what is it going to become? What it is going to become? So it is going to become minus 5 of I vector, okay? And this is going to be j plus j, that is 2 of j cap minus 4 of k cap. So when this vector is added to the resultant of this a and b, we are going to get this, right? Okay. Okay, I hope it is fine to everyone. Now let's try one more question. See, more questions you do, more will be your concept. So let's suppose there is a vector, vector a, okay. A vector has a length of, or we can write is of length 2 centimeter and is 60 degree above x-axis, 60 degree above x-axis. So here above means from x-axis, right? In the first quadrant, in the first quadrant, in the first quadrant, okay? Now vector B, now vector B is of length, is of length 2 centimeter, vector B is of length 2 centimeter and 60 degree below, 60 degree below the x-axis, 60 degree below the x-axis in fourth quadrant, okay? So remember na, this I, this J thing, okay? So this AX, AY, AZ, all these are the components of some vector in these directions, okay? And later on from there only we come up with this Cartesian thing, okay? Don't forget that the sum of vector A plus vector B is a magnitude, is of magnitude, is a vector of magnitude and direction. Okay, please go for it. Please go for it. You have to give the answer to this. Very, very simple question, no? Very, very simple question. So you can do this in any way you want. You want to do it in Cartesian way, you can do that way also. If you want to do the other way, okay, the previous way, that way also you can do. Please go for it. Please go for it. I'm very sure we can do. Please go for it, Bina. You live students and you can respond to me. Live students can respond, beta. So vector is of length 2 centimeter, okay, and is 60 degree above x-axis. So if I draw this vector, so this is going to be the A vector, na? Okay, which is having the length of, so I'll just make it as A, okay, in x-axis in the first quadrant, and there is one more vector, that is the B vector, and it is again of length 2 centimeter, and this is 60 degree below in the fourth quadrant, so this is B vector. This is B vector, okay? The sum of A plus B is a vector of magnitude and direction. Is a vector of magnitude and direction. Now see, you can do it in any way you want. You can do it in any way you want. So one way could be the Cartesian way. Okay, so see, you don't have to use no much of the brain, but right away you can write. So A vector, it is the AX, AXI, Okay, so this is 60 degree. So what is its component in A direction? Okay, what is its component in X direction? So sir, its length is 2 cos 60. 2 cos 60, that is 1. Okay, so can I write 2 cos 60? Because this angle is 60 na, I can. Okay, plus its component in Y, that is going to be 2 sin 60. So 2 sin 60 is equal to, chalo, let's see. So it is going to be 2 sin 60 j cap. Now in the form of Cartesian, can I write this vector A as 2 cos 60, that is 1. So 2 cos 60, that is 1. So it means it is I. It means it is I, and 2 sin 60, that is 2 into root 3 by 2. So it will become root 3 of j. Do you agree with that? Do you agree? Yes or no? Yes or no? And both these components, now please think, both these components are in positive direction. Okay. So this is the A vector. So its component will be in positive y direction. So we have written plus j. The component, horizontal component, will be in positive x direction. So we have written plus 1. Now similarly, if I write the B vector, now component of B in x direction is going to be 1 again. So how this is also 60 degree. The length is 2 centimeter, and so we are knowing about this. The length of vector, it gives the magnitude of the vector. So 2, you take the component in this direction. So 2 cos 60 is equal to 1. And now if you see, this is along the positive x direction. So I have written plus 1. Now, if you see the vertical component, it goes in the minus direction. So I can write minus of root 3 of j. So why you are writing minus of root 3, sir? Because see, if you see this vector b in y direction, if you think of the component of it in y direction, this is in negative y. This is going into the negative y direction. So I have used this minus sign. I have used this minus sign. Are you getting my point, Bida? Are you getting my point? Okay. Okay. So now if we, so what we wanted to do, sir, so we wanted to have the magnitude and direction of this vector. So we wanted to have the magnitude and direction of this vector. So if we sum these two, so what is going to be the resultant? Resultant is going to be vector A plus vector B. And now if we are adding them in Cartesian, 1 plus 1 will become 2i, and plus root 3 minus root 3 will become 0. Now from here you can clearly see the magnitude, which is 2, and the direction, which is positive x direction, Okay, so you could do this from parallelogram also. So two vectors, okay, whose magnitude are same. Two vectors whose magnitude are same, and they will be exactly in the middle of it. Okay, so you can use the law of parallelogram, of course, as well, or you could use the component as well. Now see, if I have to do this question in the examination, see, you don't have to know go this far. Now please see, this much we have to understand, and this much we must be doing in the forces and all, otherwise it will go too lengthy. Now this is 2, this is 2, this is 60 degree, this is 60 degree. Now please think of the components of these two vectors in x direction. So 2 cos 60 from here, 2 cos 60 from here, 2 cos 60 from here, 2 cos 60 from here. So basically it will become 2 only. Sir, how come? 2 cos 60 is 1, 2 cos 60 is 1. So both vectors, the component of these two vectors are going to come into the same direction. Two vectors in the same direction can certainly be added. Okay, so you are adding these two components together. Now if you see the vertical component of this 2, this is going to be 2 sine 60, right? It is going to be in the upward direction, and 2 sine 60, it is going to be in the downward direction. So right away you can say there is no vector left. Okay, a vector pointing upward, a vector pointing downward. So two vectors in opposite direction, when they are added, okay, so their magnitude will be subtracted. Simply we have seen all these things. Okay, so this way also you can do. So right away we can say that when these two are summed up, right away we can say when these two are summed up, the resultant is going to be in the x direction, and it will be summation of the x components of both these vectors. Okay. Okay, now let's do one more question. Now we need to find vector A plus vector B and vector A minus vector B if A vector makes angle 37 degree with positive x-axis and B vector makes angle 53 degree with negative x-axis, okay, where magnitude of A is given as 5 and magnitude of B is given as 10. Now please go for it. I'm very sure we can do it. Please go for it, my dear. Please go for it. I'm very sure we can do. Please go for it, beta. Please go for it. Very, very simple. Very, very simple. So, sir, we know to do them from the parallelogram law as well. We know to do them from this, triangle law as well. And now we also have learned to do them with this Cartesian thing. Please go for it. Please give it a try, guys. Please give it a try. Try करिए. See, very simple. You can do it very, very simply. There's nothing in this that you cannot do. Please try to do it. Let's try to do it. So how we can do it, guys? How we can do it? So find vector A plus vector B and vector A minus vector B if A vector makes angle of 37 degree with positive x-axis and B makes angle of 50 degree with negative x-axis. So how we are going to do that? So sir, we are having two vectors. One is vector A, okay. It makes the angle of 37 degree. So we are having a vector A and it is making an angle of 37 degree from positive x-axis. So obviously it is somewhat like this. And B is the vector that makes the angle of 53 degree from negative x-axis. So obviously this is going to be the B vector. This is going to be your B vector and this is 53 degree. This is 53 degrees. So now what is going to happen? So, sir, now I can write this A vector in the Cartesian. See, we know the addition subtraction of these through the parallelogram of it. Okay, we can use parallelogram law. We have seen subtraction also. So we are doing the same sort of thing through Cartesian, and ultimately you can go with any way that you want. Okay. If I ask you that if at all we haven't learned the Cartesian yet, so what is the use? Why we are reading? Because all these concepts we can apply in three dimension also, no? Okay, and sometimes if the geometry gets too complicated, you can do this also. Okay, okay, though it is a little lengthier process if you feel. Okay, if you can apply the graphical way or parallelogram way, that is less time consuming, because here first you have to think of it. You have to take components. You will write it in the Cartesian form. Then you go for finding the resultant. Okay, so it makes somewhat a bit lengthy, but still we must know it. It is more easier. Okay, it is a long way around, but it is easier. Okay, that is the short way, but there are too many things to be, taken care of. Okay, so now what is going to be the A vector? So the component of this A in the x direction, so it is going to be how much? So the magnitude is 5, so it is going to be 5 cos 37 I cap. Okay, 5 cos 37 of I cap, right? Okay, plus, see, now the component of this is going to be in plus y direction. So we know this is plus x, this is plus y. So obviously this is minus x and this is minus y. This is minus x and this is minus y. So what is going to happen? So 5 cos 37 of I. Now it is the other component is going to the positive y direction. So it is 5 sine 37 of j, 5 sine 37 of j cap, right? Wonderful. Now, if I write the b vector, so what is going to be the b vector? So, b vector is going to be, now see, the component of b vector in x direction is going to be in the negative x direction. So, it is going to be minus of 5 cos 53 degree, minus of 5 cos 53 degree of I cap, okay, of I cap, plus, now see, this other component is going to be in the positive side, positive y direction, so it is going to be, okay, so what is the magnitude? Magnitude of this b is 10 actually, now. This is 10 actually, so I'll have to correct it. So magnitude of b is given, it is minus of 10, okay. Why minus I am using? Because this is in negative x direction, so it is in the direction of minus I. Okay, minus I. Okay, so cos 53 of I cap. Okay, and this is the y component of it, so it is positive y direction, so we can write plus 10 of sine 53, sine 53 of j cap, right? Now I told you something about this thing, na? This 37 and 53 degree one triangle. So what did you tell us? So I told you that if this is 4, this is 3, this is 5, so this is going to be 37 degree. And if this is 4, this is 3, and this is 5, this is going to be the 53 degrees. So this is the standard triangle. You are expected to remember this thing. Are you getting my point? You are very much expected to remember this thing. Okay, these two 53 and 37 angle. Okay, all right. Now how we can proceed? So simply now let's make them a good number. Let go of this cos sign thing. So 5 cos 37. So cos 37, that is going to be 4 by 5 of I based upon hypotenuse plus 5 of sine 37. So sine 37 is going to be 3 of 5 of j. Okay. So obviously A vector is going to become A vector is going to become 4 of I plus 3 of j. 4 of I plus 3 of j. Now similarly, if we talk about this b vector, so b vector is going to become how much? Now for b vector, what is b vector? So it is minus 10 of cos 53. So cos 53 is 3 by 5. Okay, so minus 10 into 3 by 5 of I plus then now sine 53 is 4 by 5. It is 4 by 5 of j. Okay, so this is going to be minus 6 of I. This is going to be minus 6 of I. Okay, plus 5, 10, 2, and 4, that is 8 of j. Minus 6 of I plus 8 of j. So this is going to be your b vector. This is going to be your b vector. So we have to now find a vector plus b vector and a vector minus b vector. So what is going to be the a vector plus b vector? What is going to be the a vector plus b vector? So sir, we can write it as a plus b. So 4 minus, so it will become 2i vector. It is going to become 2i vector plus 11 of j vector. 11 of j vector. Now vector A minus vector B. Vector A minus vector B. It is going to be vector A minus vector B. This is going to be 4i plus 3j and minus. So when you are subtracting it, now see, you cannot always, you cannot always go by, everything you don't have to do like that. So what you can do guys, can do guys, so A minus B. So 4i plus 3j minus of minus 6i plus 8j. Okay, minus 6i plus 8j. So it is going to be 10 of I, 10 of I plus how much? Okay, so it is going to be 3 minus 8. So minus 5 of j. 10 of I minus 5 of j. Okay. Now, if you call this like previously what we call it R. Okay, so let's call it here also. So let's suppose this is R vector and let's suppose this is R dash vector. This is R dash vector. So see, so from addition subtraction, so we used to get the magnitude of the resultant and the direction of the resultant. So same thing that you can find here also. So sir, if you want the magnitude, sir, we will be getting 4 plus 11 square. Okay, 2 square, that is 4. I have written directly. And in any case, if you want to see the direction of this vector, so you can get that also, right? You can get that also from any reference. How? Don't you remember tan theta is equal to ay upon ax? So we can use that and we can firstly think that this vector is in which quadrant, right? Okay, now similarly this r dash vector. So what is the magnitude of it? So we can write 10 square plus minus 5 square. Okay, so see the same way guys, same way again, in the same way again we can get, in the same way again we can get this thing, that is, in the same way again we can get this thing, that is the resultant of a vector. Okay, so the resultant of the vector we could find by the law of parallelogram of force, the law of, the law of parallelogram of force, the law of this, triangle of force, either by the graphical way, the analytical way, or we can do the same thing by this Cartesian thing. Okay, so for that, first you have to reduce your vectors into Cartesian, then sorry, then you can have them added, and once they are added, you can then go for finding out the resultant. Okay, then you can go by finding out the resultant. Now let's do one more question. So we have a force acted upon, let's suppose a force acted upon by three given forces, a force acted upon by, let's say, a point, a body. Let's write a body or a point. Okay, let's say a point acted upon by three given forces. Okay, three given forces is under equilibrium. Is under equilibrium. Okay, is under what? Is under equilibrium. Okay. Now, if let's suppose that the first force is 10 Newton, okay, okay. The second force is uh, 6 Newton, let's suppose, and uh, then we have to find the value of F3 vector, okay, and angle theta. I'll give you the figure, okay, I'll give you the figure. So we have this, see, this is F1, this is 37 degree, okay, this is F2, that is theta, okay, and we have this F3. We have this F3. Now, can we please try this question? Hello, Dinesh. Yeah, hello, Dinesh. Sorry, I just saw your message. Actually, it is not. Yeah, yeah. Hello, Dinesh. How are you doing, beta? I'm really sorry I saw your message a little late. Okay, so let's try this question. Now, what do we mean by equilibrium? What do we mean by this equilibrium? Okay, so when we say a body is under equilibrium, that means that the summation of net force, okay, when a body is in equilibrium, what is the meaning of this equilibrium thing? So when body is equilibrium, simply it has one meaning, that net force acting on the body has to be equal to 0. Okay, so this could be any force in, this could be forces in any given direction, any particular direction, let it be x, y, z, or any other direction, or it can be also moments. Okay, okay, so when some body is in an under equilibrium, the sum of all forces in any particular direction is going to be 0. Okay, okay, now can we try it? Can you try it, please? Please go for it. Please go for it. So here we have to find this theta and we have to find this thing. So see, you can do, so see, playing with the forces, okay, playing with the resultant of forces is of utmost importance. Okay, so one way you could do it, that's we do the conventional way, like the net force is equal to 0, so we'll write the F1 force plus F2 force plus F3 force. Then we take components of each force, write the Cartesian form, and then do it. But there is one more way, and that seems to be easier way. So as I said, so whenever we say equilibrium, whenever guys we say equilibrium, so equilibrium means that, see, very simple. This is going to, we are going to use this further also. So see, forces, summation of forces in x direction must be 0. Summation of forces in y direction must be 0. Summation of moments must be 0. So I have written x and y direction, but it can be any direction for that matter. Okay. So summation of forces in any particular direction has to be 0. Then the body will be in equilibrium. Now, what are the forces? Now, please just by observing here, you can solve the question. Now, if we see in x direction, okay, if we see in x direction, there will be no component of this F3. Why, sir? Because this angle is 90 degree, na? So any vector do not gives its component in 90-degree direction. Are you getting my point? No vector will give its component in 90 degree. Why so? Because let's take the component. So it will become f3 cos 90, and cos 90 is going to become 0. So very simple. Any vector is not going to give any. A, a vector is not going to give any component in the perpendicular direction. Okay, in its perpendicular direction. So this f3 is not going to have any component in x direction, right? Okay, so now if I see in x direction, can I see? Now just observation. So now if I write the component of this f1 in x direction, do you believe that this is going to be f1 sine 37, f1 sine 37 right away? Okay, the component of this f1, see, we are coming up to the forces also very soon. So in the when we start dealing with the forces, all this thing is like in every chapter we have to do it, more or less in each of the problems. This is a very good evening. So today, so why are you so late? Actually, today what happened? The session was at 3:30. So I streamed it, but some YouTube error happened. I didn't know. So that is why that old stream I have to delete. Okay. Okay. So you are late. I thought you came at time, and afterwards due to the technical. So today one technical glitch happened actually, na. So what technical glitch happened, sir? So the technical glitch happened that sir, we previously have put another link, but afterwards that link couldn't work, so we have to come up with another link. Okay, it's okay. So we are dealing with the addition of vectors in Cartesian. Okay, we are dealing with the addition of vectors in Cartesian. Right. So what it is going to be now? So see, I am talking about the equilibrium. I am talking about the equilibrium. So see, when equilibrium happens in, so equilibrium is a word, it's a term, it's a it is a phrase, whatever you say it. Okay, it is concerned when forces are into picture. Okay, so it basically means that the forces in any particular direction has to be zero. The forces, the summation of forces in any given particular direction is going to be zero. So see, one way is you write this f1, f2, f3 in Cartesian form, then think so many things. So we can right away do it. Now we have to save time also. So what is the component of f1 in this x direction? So it is f sine 37. Okay. Now I have considered this direction to be positive because this is positive direction only, plus x. So I have considered this plus. Now what is going to be the component of this f2? Okay, in x direction. Now if we see the component of f2 in x direction, this is going to be f2 sine theta. This is going to be f2 sine theta. So this is in opposite direction. So can I write f2 sine minus f2 sine theta is equal to 0? Is equal to 0, right? Yes, sir, absolutely we can write. Now from here, can I write that sine theta is equal to, so f1 sine 37, f1 sine 37 upon f2. So what is this f1? So here we are taking the magnitude. So it is going to be 10 sine 37. So we know sine 37 is, so remembering that triangle now. Okay, so 3, 4, 5. Okay, this triangle is very important. So this is 37. This is 37. So sine 37 is going to be 3 by 5. Okay, 3 by 5. And f1 is 10. What is f2? F2 is 6. F2 is 6. So what we are getting from here? So we are getting 1, right? We are getting 1. So what is going to be this theta? So the theta is going to be 90 degree because sine theta is equal to 1. So theta is equal to 90 degree. So we got this theta. Now what is going to be this f3? What is going to be this f3? Okay. Can you tell me what is going to be this f3? Is that? Can you tell me what is going to be this f3? Hmm? Can you tell me what is going to be this F3? Okay, you do from the next question. No worries. Now see, simple. So one way in the vectors, you can first take them to the Cartesian form, then do addition, subtraction. We are doing it directly. Now think in this way. Now we come to know that what is theta. We come to know what is theta. So now theta is 90. So when theta is 90, that means this is the F2, this is the F2, this is the F1, this is the F1, and this is going to be the F3. This is going to be the F3. Okay. Now, will this F2 is going to have any component in this direction, y direction? So it is not going to give any component in the x direction. So why so? Why so? Because we know no vector is going to give a component in positive x direction. No vector is going to give a component in positive x direction. Are you getting my point? No vector will give component in positive x direction. Are you getting my point, beta? Are you getting my point? बोलिए बोलिए right? So we know this thing, sir. We know this thing. We know this thing, right? Now see what is going to happen here. So now this is F2, this is F3, this is F1. So what we can do? So now F2 is not going to give any component in the y direction. So the component of F1 in y direction, what it is? So it will be F1 cos 37. It is going to be F1 cos 37, isn't it? Now F2 is not going to have any component. Now see. One force upward, one force downward. Okay, okay, and they must be in equilibrium. So if I sum up the forces in y direction, it is going to be F1 cos 37. Okay, F1 cos 37 minus F3 is equal to 0. So right away we can write F3 is equal to F1 cos 37. Please tell me yes or no, is it fine or not? Please answer me. I'll just come up to the next question. Don't worry. Just one last thing. Just one last thing in this. Okay, so what is cos 37? What is cos 37? So cos 37 is 4 by 5. So F3 is going to be, what is this F1? Sir, F1 is given to be 10. Okay, 10 and cos 37 is 4 by 5. So this F3 is going to be 8 Newton. I hope it is fine to everyone. Yeah, please answer me. Yes, sir, absolutely fine. Let's do one more question. Let's do one more question. So what was the agenda today? The agenda today was that we were doing the addition of vectors. We were trying to understand that what is the addition of vector, how we can add the vectors in Cartesian. Are you getting my point? How we could add the vectors in Cartesian. This is the agenda today. And I am now, we have discussed that. Okay. And again, we have discussed it like with why it happens that way and everything. Okay. You can give some time to watch, the recording. Okay. So a particle is under equilibrium. So similar question I'm going to give you. Under, yeah, under the presence of, okay, under the presence of four forces, under the presence of four forces as shown, as shown. Okay, now you need to find F1 and F2. What you need to do, you need to find F1 and F2, right? Please observe. Okay, let's try this one. So this is F1, let's suppose, and this is F2, let's suppose, F1, F2, okay, and this is your, how much? This is your 45 degree. This is again 45 degree, right? This is again 45 degree, and this is 90 degree. Please go for it. Please go for it. Okay. You need to find F1 and F2. Please go for it. I'm very sure we can do. Please try it. Equilibrium means simply the force in any given direction. The force in any given direction, the sum of forces in any given direction is going to become zero. Okay, so body is in equilibrium. Are you getting my point? Then the body is said to be in equilibrium. Please go for it. Please go for it. Please go for it. No, wrong answer. She said wrong answer. Yeah, F2 is seems correct. F1 is wrong. How come? No, see, very, very simple is question. And see, first of all, what is equilibrium? So in X direction, Y direction, or any direction for that matter, if X direction, Y direction, or any direction in that matter, the sum of forces has to be zero. Now please observe. See, very simply we can do. Very simply we can do. So see, first of all, F1 and F2 are 90 degree with each other. So basically, when two vectors are 90, force is a vector quantity. So when two vectors are vectors and they are at 90 degrees, they do not give components in in each of their directions. Okay. Now, if I see the equilibrium, so let's do firstly the equilibrium of this y-axis. So you can do y-axis, you can do x-axis, whatever you want. So I can write 2 cos 45. So this is in positive y direction. Okay, so in equilibrium also you don't have to follow this positive. Okay, you can consider one direction to be positive, other to be negative. Okay, because you are ultimately equating to the zero, right? Okay, so that doesn't matter even. Now we can write 2 cos 45. We can write 2 cos 45 plus what is this F2? So this is F2, we don't know. This 1 Newton. So again, its component is going in the upward direction. So it is 1 cos 45. Okay. Now this F2. Now F2 is 0. So this is going, sorry, this F2 is in negative y direction. So minus F2. Okay. So 2 cos 45 plus cos 45. So it will become 2 by root 2. Okay, so it is going to be 2 by root 2, that is root 2 plus 1 by root 2. Okay, and it is equal to F2. So F2 is going to become 3 root 2. Okay, when you take the LCM, it will become 3 by root 2. It will become 3 by root 2. No problem at all. Right? Yes or no? Please answer me. Please answer me. I hope yes. Okay. I hope yes. Okay. Now let's go back to this x direction. Now x direction if we do, so I have F1. This is in positive x direction plus. Now what is the component of this 1 Newton in the x direction? So it is going to be 1 cos 45 and I can see that this is in the direction, I can see that this is in the direction of x only. So 1 cos 45 is going to be now this 2 Newton. Now this 2 Newton, so it is also giving a component in x direction, but its component is in minus x direction. So can I write it in minus? So minus 2 of cos 45 minus 2 of cos 45, and this is going to be 0. This is going to be 0. Okay, so from here what I can do, so I can write it as 1 by root 2, okay, minus root 2, okay, 2 by root 2, so it will become root 2. So what is f1 going to become? So it is going to become 1 by root 2 from here. See, when you take the LCM, 1 by root 2 minus root 2, it will become 1 minus 2 by root 2. Now 1 minus 2 by root 2, 1 minus 2 by 1 minus 2 by root 2, okay, 1 by root 2 minus root 2. So root 2 will be the LCM. Root 2 will become 2. So 1 minus 2 by root 2. So it is minus 1 by 2. It goes on the other side. It will become 1 by root 2. It will become 1 by root 2. Is that clear, Vida? Please answer me. Right? Okay. Okay. Now in the similar way, so this is sort of the application. This is sort of the application to this resolution, Cartesian, and everything. So, guys, in this session, what we have seen? So, we have seen that. So, lastly, see, we did just I'm giving you a brief overview. Okay, so in the next session, we'll be starting with the position and displacement vector and the scalar product of the vector. So, these are interrelated topics. Okay, we'll be doing into them. Okay, okay, so okay, and see what is the application of the dot product. So there are many applications to it. Okay, so we'll talk about it. So in this session, I'll just give you a brief overview. So what we have done, so we have done the Cartesian vectors in Cartesian previously. We have introduced to that. Okay, now we did the addition. So in addition, simple, remember one thing: when two vectors are added in the Cartesian format, okay, their I components, their Y components, that is the components with I, components with J, components with K, all are added. All what happens? All are added. Okay, okay, and in the same way, we have done some questions. We have seen the uses of it, and finally we have understood the equilibrium. So all of it in a way is application to resolutions only, right? This is somewhat the application to the of the resolutions. All right, okay, okay, so from this point onwards we are going to continue in the next session. Oh, she say okay. Okay, so see, this is something that you can manage by yourself, and you can always watch the recording. So you can please try to come in the live session if you could. Okay, and if you couldn't, then it is fine, and you can see the recording. Okay, so thank you, no problem at all. So guys, that will, I'll keep it to this point in this session. Those who are watching this session, if you haven't subscribed yet, please do subscribe the channel, and I'm looking forward to have a great journey together. So with this, thank you very much. Have a good day, and we'll see you in the next session.